Hello and welcome to our presentation. My name is Cameron Orr. The other group members are Nick and Chris, and our project is the Automatic Merge Conflict Resolver. So first of all, what is a merge conflict? Normally developers use a tool called Git, which is actually a branching tool allowing multiple users to work on the same code at the same time without having to worry about the others' changes in real time. And so when a user wants to bring their code together with another developer's code, it's possible that there might be changes to the same lines of code. And so Git has a more simple algorithm that takes both of these changes and puts them in place. But an issue might occur when a user changes the same line as another developer. And so in this case, this would be called a merge conflict. So the problem with this is that yes, a developer is able to do some of these merge conflicts on their own, but when you get to larger code bases at larger companies, there can be a lot more merge conflicts that you need to go in and resolve. And so this process can take anywhere between 5 minutes to potentially hours, depending on what you're working with. So our solution was to design an automatic merge conflict resolver that can not only resolve any type of conflict, but is optimized to resolve greater than 100,000 lines of code in under 1 second. And so that potentially our process can be brought down to just 5 seconds in some cases. So our program has a set of common merge conflicts that we are able to recognize and resolve, but then we also have a set of edge cases that we handle using a machine learning LLM. And this LLM allows us to catch any of the merge conflicts that can't be caught by our pattern matcher. So first I'm just going to show you what it actually looks like going through and resolving these merge conflicts manually. So here for this merge conflict that I'm showing you, I'm just outlining that this is going to be an import conflict. So when these two branches get merged together, as I'm typing in the terminal, they will actually have a merge conflict where there are two import statements and they both need to be placed in. So that's why I accept both changes. So for this one, this is actually going to be an append merge conflict. In Python, you're able to use the append function, or you're able to do plus equals when you're adding to a list. And so for this, I would preferably want the plus equals so that I don't have to call a function. So for this one, this is a little bit more complex of a merge conflict, and so I'm just going to need to customize the way that I want it. I wanted the hello world 3 function call because it has the print hello in it. And so that would be the intelligent move to take. So what actually is AMCR? So from a high level, we use Python to program it. We use a command line tool to get all of the merge conflicts and put them into a readable format. Then we're able to identify what type of merge conflict it is. Then we give it to the resolution algorithm. And we output the resolution to the same file. And so this type of tool is able to be run on any number of merge conflicts in the entire code base. And so essentially it just reads through all of the files and tries to identify the merge conflicts. So what are the benefits of our project? Well, like I was mentioning, this saves a lot of time, and so this will lead to increased productivity for developers since, like I was saying, for these larger projects, you don't want to go through all of those tedious merge conflicts. And this can also be useful for developers who don't have a really good understanding of Git, and as well just prevents user error, because no matter how experienced you are with Git, you can definitely just run into human error. And now I'm going to give you a demonstration of how our tool actually works. So for that same import conflict that we had before, as you can see, I just type in the merge tool and it gives us the same result as we wanted. So next, for a second example that I showed, we have that append conflict, and again, just running that command, it immediately just gives us the same result. And then lastly, we have this complex merge conflict that we had before. And so for this one, this is not part of the library that we have, and so this actually calls the machine learning algorithm and is able to identify this merge conflict, and it actually gets the exact same result. So in that last example, I was able to demonstrate just how much more efficient this is than regular merge conflict resolution, even just on these single examples of one merge conflict at a time, let alone across multiple files in the code base. But how is it actually built? So from a lower level, we actually use the git merge tool, and essentially that allows us to get all of the merge conflicts and put it into a file so that we're able to read it. And then we use our pattern matching algorithms to identify the merge conflict and what type it is. And then we go ahead and handle it by calling the appropriate handler for it. And then once we've resolved all of these conflicts, we then output what the result is to the user, which is what they're able to see and what I demoed in the video. So for improvements that we can make in the future for this project, that would be expanding covered conflicts libraries, and this would just help improve the performance so that we don't have to use the machine learning algorithm. Increase the test capacities, because it's always better to have more tests, and that would help ensure that no users run into any issues. And then adding user configurability, because just in case there is a case that isn't covered, then we would be able to ask the user what they want to actually resolve it as. And finally, for the setup instructions, these will be in the README file in the code base. And yeah, thanks for watching our presentation.